Today we are wrapping up lesson 4.1 and moving on to 4.3. So at the end of 4.1 there were these two formulas, one for linear speed, which is arc length over time, and one for angular speed, which is central angle over time. However, we're not going to use either of these. If you're a very formula person, you can still try these and see how they work for you. But I have a different method, and so let's get to the problem so I can show you how that works. A 15-inch diameter tire on a car makes 11,760 revolutions per minute. And then the first question is find the angular speed of the tire in radians per second. Now the way I like to go about this question is you're going to take this 11,760 revolutions per minute and treat it like a conversion table like we've maybe done in science back in the day, or maybe it was old math, where we're trying to convert now revolutions into radians. And so what we're going to do there is going to be how many radians are in a revolution. Now a reminder, if a tire is going all the way around, that's 1 pi, 2 pi radians. So 2 pi radians per divided by 1 revolution. And again, notice how the revolutions in the denominator, so we'll cancel like this, and I'll be left with radians left over. The next part is I need seconds in the denominator. I have minutes, so how many minutes and seconds, right, are there? And we've got 1 minute is 60 seconds. Doing it this way, why not minutes on the bottom? Because I want minutes to cancel with minutes over here, right? Something in the numerator has to cancel with something in the denominator. And now with our calculators, we're just going to go straight over the top. 11,760 times 2 pi, and then you divide by your total of the bottom number, right? We've got 1, 1, so then it's 60, that really gets factored in here. So when we calculate this, right, 11,760 times 2 pi button, and then divided by 60, is going to get us 1,231.504 radians per second, right? We're not leaving it in pi because I put pi in there. So 1,231.504 radians per second. Now that's always worked better for me than the formulas they have. And I'm usually a formula person, so that's just telling me something there. Next, linear speed. What is the linear speed of the car in inches per second? Now be aware, once in a while they may even change the label there, right? Because we still have inches over here. But for inches per second, right, again, we'll set it up again, maybe a little bit smaller here. Then we're going to have, again, 11,760 revolutions per minute. And now I need inches per revolution. All right, so 1 revolution is how many inches, right? Just like we know it's a circle, we've got diameter is 15, so circumference is pi diameter, or 2 pi r if they give you radius. So in this case, diameter is 15, so this is going to be 15 pi inches. And this will, again, cause this revolutions to cancel here, and we'll have inches per minute. But now I need to divide by 60 to get second, because 1 minute is 60 seconds. So I'm going to have 11,760 times 15 pi divided by 60. Now, if you look at the difference between the two answers, our difference is really we multiplied by radius. Because we had 2 pi before and we need 2 pi r. So it's not a giant difference between the two formulas, but we end up with 9236.282. And inches per second. Sounds a lot, but if you math it out, I think that was 35 miles per hour. And that wrapped up 4.1's lesson. Moving on to 4.3, right triangle trig. Now the reason 4.3 got swapped ahead of 4.2 is because 4.2 is a unit circle, and 4.3 basically explain where the unit circle values come from. So it makes sense to do the triangles first and get there. So labeling the triangle, right? If we have an angle here, right, from that angle, and again, it's a right triangle, so we have three sides. We've got hypotenuse, and then from this angle, this side right here is adjacent, and the side that's left is opposite, right? Like what's opposite our angle, right? So just like SOHCAHTOA, which is what we have next. Sine of the angle is opposite over hypotenuse. Cosine of the angle is adjacent over hypotenuse. Tan is opposite over adjacent. Now, hopefully you've heard this before. Right, we got SOHCAHTOA. Okay, that's where that comes from. If you are not familiar, you will need to study this. Should have been covered in geometry. Next, we have cosecant is hypotenuse over opposite. Secant is adjacent over hypotenuse. That is wrong. It is hypotenuse over adjacent. And then cotangent is adjacent over opposite. Because these are reciprocals of one another. So we'll learn that later. What does that mean? Right, they're kind of each other flipped. So find the exact values of the 6 trig functions, our first question. So they have angle theta, and again, might not enunciate it the best because it's theta is what we're talking about. And so we need to find the exact values of the 6 functions. And I've got 2 of 3 sides of a right triangle, so I can solve for the last one. Because again, just a reminder, this one's c, so c squared equals a squared plus b squared. Whatever you want to call this side, technically it is little a for adjacent. And then solving, we've got 49, and then we're going to subtract 16 from each side, and then square root. And I get 33 is a squared. So then when we square root, we're not plus or minusing here, square root of 33 is a. So the a is square root of 33. And now I'm doing SOHCAHTOA, right? What is sine? Opposite over hypotenuse. So again, labeling. This one's opposite, this one's hypotenuse, this one's adjacent. So what is O over H? O is 4, and H for hypotenuse is 7. And there's sine. Next one, cosine. Again, so what's adjacent? Square root of 33. What's hypotenuse? Right, going back to 7, right? If you're not sure where these are coming from, they're coming from these values being assigned to these letters, which stand for opposite, hypotenuse, and adjacent. And again, if you're very new at this, I highly recommend watching a Khan Academy video, because for most honors pre-calc students, this is going to be review. So we have a square root in the denominator. We need to clean it up by rationalizing, and we're going to get 4 square root of 33 over 33. Now, tangent is the only one that can be of SOHCAHTOA that could be over 1. Next, cosecant, a reminder, this one is hypotenuse over opposite, and we get 7 over opposite is 4. Secant is hypotenuse over adjacent, and that one is going to be 7 over square root of 33. And then we have to rationalize. So multiply by square root of 33 on top and bottom. And we get 7 root 33 over 33. And then lastly, cotangent is, right, A over O. Adjacent is square root of 33. Over opposite is 4. Moving on, the next one I'm going to show you, we don't need a triangle to figure this out, right? You can draw a triangle from this information, right? Sine of 2/5 tells me I can draw a triangle. This angle has an opposite over hypotenuse of 2 over 5. So that means my hypotenuse is 5, my opposite over here is 2. And again, I'm solving for adjacent using 5 squared equals 2 squared plus a squared. Minus 4, 25 minus 4 is 21. So a is going to be square root of 21. And now I have these values to fill in the remaining SOHCAHTOA and their reciprocal. So again, adjacent is square root of 21 over hypotenuse 5. Tangent, as the opposite is 2 over square root of 21. And then rationalizing, give me 2 root 21 over 21. Cosecant is hypotenuse over opposite, so that is 5 over 2. Secant is hypotenuse over adjacent, so that is 5 over root 21. And then again, simplifying that gives us 5 root 21 over 21. And then cotangent is A over O, which gives us square root of 21 over 2. And those are the 6 trig values. Moving on, special triangles. We're talking about a 45, 45, 90 triangle, which will probably be switched into this language, pi fourth, pi half, from turning degrees into radians. And we'll also go over 30, 60, 90 triangle, which is going to give us values for pi sixths, pi thirds, pi half. Some teachers teach it strictly using radians. I'm going to use degrees, and then we'll just kind of understand that pi fourth and 45 degrees are the same thing. So in these isosceles right triangles, those angles are the same. These sides are the same, so we're just going to call those sides x, and the hypotenuse is x squared root of 2. And x squared plus x squared is c. 2x squared is c. So when they, c squared. And then when they square root both sides, we get x squared root of 2 is c. So that's where that comes from. This triangle over here, 30 is the small angle, 60 is the large one. And then my hypotenuse is 2x, to my small side is x, and my long line is x root 3. So that is the basic information there. What we're going to do is go back and forth between the slides to understand what is sine of that 30-degree angle, what's cosine of that 30-degree angle, and what's tangent of that 30-degree angle. Now, if you recognize we're doing all the angles, it makes it a little hard to label, considering I'm going to relabel them in a second. But going over here, starting from 30 degrees, maybe we'll switch colors for a second, that we'll do it in red. From 30 degrees, x is my opposite, x root 3 is my adjacent, 2x is hypotenuse. So, using that information, whatever, if you need to kind of copy a mini triangle over here, that opposite's x, adjacent's x root 3, and 2x is hypotenuse. Filling in what's opposite over hypotenuse of that triangle, x over 2x becomes 1/2. So even though there was x's in there, it is 1/2. So sine of pi 6 and sine of 30 is 1/2, right? I'm going to continue on with the other ones, right? Here we got cosine adjacent over hypotenuse is square root x root 3 over 2x. And what do you know? These x's clean each other out, right? So we're going to rewrite this as square root of 3 over 2, right? You need to see where the x's went. I'll kind of leave that work there to show that canceled out. So cosine of 30 degrees, or cosine of pi 6, root 3 over 2. Tangent of 30 degrees is opposite over adjacent, which is x over x root 3. So 1 over root 3, which when we simplify gives us root 3 over 3. Continuing to 45-degree triangle. And again, you guys can keep cross-referencing if it's in your notes nice and neat. But versus swapping back and forth between slides, I'll just kind of reference this, that you can kind of pick whichever one you want to be your angle. Opposite and adjacent are the same. Hypotenuse is here. So what is opposite over hypotenuse? I've got x over x root 2. The x's cancel. 1 over root 2 becomes root 2 over 2. What about cosine? Well, it's going to be the same thing because adjacent and opposite are the same. So instead of showing all that work again, I'm just going to show you this. And again, you can look back here if you want to see it. Now we're going to get square root of 2 over 2. Finally, something different with tangent, opposite over adjacent. They're both x's, so we get 1. And now last one is we're doing from 60 degrees. So now I just need to relabel this triangle a little bit into, this is 60 degrees, so this one's now my opposite. X is my adjacent. 2x didn't change. So now what is sine of 60 degrees? Opposite over hypotenuse is x root 3 over 2x. So this is square root of 3 over 2. That looks familiar. Next, what about cosine of 60? We got a over h, giving us x over 2x, which is 1/2. And lastly, tangent of 60 is x root 3 over x, giving us square root of 3. So sine and cosine are very similar, right? We can find values that repeat all over the place. However, what's going to happen with this is this is going to become your unit circle values. Okay. So be aware, this is important information, will become our unit circle values that we'll be using throughout most of the rest of the book. So next says, evaluate without a calculator. Tan of pi fourth, right? Part of it, they would like you to draw a picture with pi fourth. These are the same, so what's tangent? X over x is 1. Okay. Or you can just start to work on memorizing. Secant is what? Secant is hypotenuse over adjacent. Now, if you're wondering how I have these memorized, each one has a code. So tangent, cotangent, that one's pretty obvious. These are, we'll learn in a little bit, are reciprocal, right? They're flips of each other. Sine doesn't have a co, so it belongs to cosecant. So even though this is O over H, this is H over O. Whereas cosine already has a co, its reciprocal is secant. Right? So even though we have A over H over here, this one is H over A. So again, with pi thirds, this is a 60-degree angle, right? So we got x, 2x, x root 3. What is hypotenuse over adjacent? I get 2. Reciprocal identities, which is what I just talked about. Sine is 1 over cosecant. Cosine is 1 over secant. Tangent is 1 over cotangent. Cosecant is 1 over sine. Secant is 1 over cosine. Tangent is 1 over tangent. Cotangent is 1 over tangent. Okay, so again, each one has one co. There's a co. Tangent is usually the easy one. That's more used to help you remember that secant and cosecant are reciprocals. Next, evaluating with a calculator. And again, as I'm kind of going through this, if you need to pause, feel free to pause your video to finish writing down. So without a calculator, or with a calculator, secant of 35 degrees, 6 minutes, 36 seconds. So reminder, this is the same as 35 plus how many minutes are there in an hour, right? 6 over 60, that's what the 60 comes from. And how many seconds are in an hour? 3,600. So they're asking, what is 1 over cosine of that? And so we can just type this into our calculator, 1 divided by cosine of that, and we'll see what we get. So 1 divided by cosine of 35 plus 6 over 60 plus 36 over 3,600. And I see I'm missing a divide sign somewhere in there. Go back, insert it, second, insert divide sign. There we go. Now, just a note, there are 2 different modes for your calculator. This question is in degree. So you can either add the degree sign, which is, I believe, if you hit, it's in the math section, I think. I could be wrong. Looking around for it. Not finding it, so my backup is second catalog, second 0. And then again, now using the green letters, hit the symbol sign, and there's degree right there. I know I've seen it around, I'm just blanking on where the degree's at right now. But if you do that, it will do degree for you, I believe. Let's see if we get the right answer. That is not the right answer, so trying again. Your other option is switch it into degree. So now in degree, I'm doing the same thing, and I get 1.222, which is the answer I was looking for. So 1.222. Sorry, that goes there. That's just the full answer. Next, cotangent of 5.4. Again, this is 1 over tangent of 5.4. If they don't give you degree sign, this one is in radians. There's no degrees here, so it's in radians. So now, switching the calculator back into radians. Now I'm going to do 1 divided by tangent 5.4. Enter, and we get negative 0.821. And that is the answer. So again, you just have to type in 1 over tangent. We didn't have to convert anything on that one. Next up are some more identities. Quotient identities are tangent equals sine over cosine, right? Because again, you're like, oh, what about OA, right? They could also be opposite over hypotenuse over adjacent over hypotenuse, which is that, and the hypotenuse end up canceling out, right? So that still is true, and this is going to be more often used in some of our kind of solving identities, right? Using trig identities, and quite a bit more often in chapter 5. So this is going to stick with us for a bit. There are also Pythagorean identities, right? Technically, you only need to memorize this one, and then you can divide, say, everything by sine squared. Sine squared over sine squared is 1. Cosine over sine squared is cotangent, and 1 over sine squared is cosecant. Or maybe we'll divide by cosine squared, and 1 over cosine squared is secant. Cosine over cosine squared is 1, and sine over cosine squared is tan. So if you can memorize one, you can manipulate to figure out the others. And that one is not going to be used as much in this chapter. The Pythagorean ones are used a lot heavier next chapter. So, using trig identities to transform one side into the other. Now, most of these are going to involve reciprocals or changing things into sine and cosine. In this case, you can pick, I like to pick that cotangent is 1 over tangent. So now I have tangent over tangent, or tangent of theta over tangent of theta, which is 1. And that's it. We're not doing any extremely hard ones yet. Well, we're going to start with some easy ones off the bat. Next, a little bit harder, tangent plus cotangent over tangent. There's a couple different options here. I believe when I've done this in the past, I've just turned these all into, to show you that we can kind of switch this into looking like this. And again, to better explain this part, we basically split up the fraction, right? Because if this was 3 plus 5 over 8, we could write it as 3/8 plus 5/8, right? So that math works. You cannot do the same split if there's a plus in the denominator. That doesn't work. But in this case, I've got 1, and now I have to explain why that one's going to equal cotangent squares. And some people are like, wait, what? So going back, what is cosine squared equal to? Sorry, cosecant squared equal to? Right here, cosecant squared is 1 plus cotangent squared. We have the 1, check. Now we need to turn 1 over tangent, or cotangent over tangent, into cotangent squared. So watch this. We're going to split this into cotangent times 1 over tangent. And what's 1 over tangent? It is also cotangent. So this becomes cotangent times cotangent, and therefore 1 plus cotangent squared equals cosecant squared. Now just a little note, why do they put the square here? Why don't they put it here, right? Well, that would look like the angles being squared, right? So they don't want to be confused there. That could happen. So they put the square here to say that's like x squared, the whole piece squared. Okay. So just a little note as I saw that popped up. And again, this is the advantage of using those Pythagorean identities. But again, it won't pop up that much in this lesson. Next one, cosecant times tangent is secant. This is one where you just want to turn everything into sine and cosine. I've got 1 over sine. Tangent is sine over cosine. And diagonals are going to cancel here, right? These signs cancel and we get 1 over cosine, which is secant. And that's what we wanted for our answer. Now the other important thing, if we're not doing very hard ones, is 1. You can only work from one side. So generally you're going to pick the uglier looking side. or the more difficult looking side, and work with that one. You can't subtract or divide both sides by a cosecant, right? You can't do things like that. So, moving on. Solving some triangles for x, okay? Now this is old SOHCAHTOA, right? You want to label, what do we have? I've got opposite and adjacent. So, of SOHCAHTOA, which one uses that? I've got TOA for tangent. So now I'm going to say tangent of this angle, 35 degrees, equals 5 over x. And now we're going to kind of proportion to solve, right? This is technically like this, so when you cross multiply, x times tangent of 35 is 5. And then we're going to divide by tangent of 35 on both sides. And you'll notice that these just did a little flip here. The x and the tangent switch spots, and we get x is 5 divided by tangent of 35. Now a little note, we are back in degrees. I'm not trying to be a pain in the calculator, but it is a pain in the calculator. So we're going to plug this into our calculator. 5 divided by tangent of 35, and we are in degrees. And if you can't remember what mode you're in, fortunately in your calculator, kind of right up top, it says normal, float, auto, real, degree. That tells you what mode it's in. If you have a really not that great calculator, I might say D or DEG for degree. And I got 7.141, rounding to the third decimal. And how do you know if this answer makes sense, right? So this angle is 55, and from geometry, 55 is bigger than 35, so x should be bigger than 5. So to me, makes sense. 7.141 is bigger than 5. One more of these, and then we've got, again, what do we have? We've got opposite and hypotenuse. And this is adjacent, that's missing, so we're using sine. So sine of 40 is x over 2. We need to solve for x, so multiply by 2 on both sides, and then we're ready to go. 2 sine of 40 is x, and we're plugging it into our calculator. I don't need to change modes again, I'm already in it, so 1.286, 1.286, and in this case, 2 should be larger than my answer, so it does make sense that 1.286, x is smaller than 2. Last set, find the value without a calculator, and this would be a situation where you just go back and see what triangle is it, because these are ones we haven't really done much, right? So what has an opposite over hypotenuse of 2 over square root of 2? It's going to be this one, right? X over x root 2 became 1 over root 2, became that. And what was the angle? 45 degrees, but it wants radian. So going back, you have to go back 6 slides, 7 slides. Where was the one that equaled that? What was the angle? And we've got right here, sine of pi fourth, kind of wrote over. So pi fourth is our answer there. And then one more, cotangent undefined where. This one just one you kind of have to know, so don't worry about it. It's 0. We'll get that in the circle in a little bit. And that wraps up today's lesson. Feel free to check Google Classroom for the homework.